Open a folding phone under a hard ceiling light, and the screen tells on itself. A bright line appears exactly where the display bends. Samsung's new Galaxy Z Fold8 makes that line much harder to notice, but here is the trick. The crease did not disappear. Engineers changed the path the display takes through the bend, how its layers share stress, and how the finished surface reflects light. That means the problem is not one magical sheet of glass. It is a coordinated system, hiding a mechanical compromise in plain sight. To see how, we have to peel the screen apart, bend it on purpose, and follow the stress into the hinge. A fold is not just a line, it is a fight over distance. Wrap a strip around a curve, and its outside edge must travel farther than its inside edge. The outside stretches, the inside compresses. Somewhere between them is a neutral plane that changes length the least. In one sheet of one material, that plane is easy to picture. A display is different. Its layers have different thicknesses and stiffnesses, so the neutral plane can shift away from the part you most want to protect. Every close sends tension through one side, compression through the other, and shear through the bonds between them. When the phone opens again, tiny residual changes in those materials can leave a shallow valley or ridge. The crease is the visible footprint of a bend that the stack cannot simply forget. Now peel back the word screen. A published foldable AMOLED model stacks a protective film, transparent adhesive, ultra-thin glass, another adhesive, a polarizer, the light-emitting panel, base films, more adhesive, and a patterned metal support. That is a representative research stack, not a teardown of the Fold8. The important idea is that these layers must behave as one display while sliding by microscopic amounts as they curve. The adhesives do more than hold the sandwich together. They transmit force, allow shear, recover after deformation, and keep the layers from separating. Make a bond too rigid, and stress can concentrate. Make the support too weak and the open display loses stability. Make the stack too thick, and its outer surfaces travel a longer path around the same bend. A good foldable screen is not the most flexible layer. It is a tuned stack whose layers bend together without all feeling the same load. The simplest lever is bend radius. Bend the same strip around a pencil, then around a wide marker. The pencil forces a tighter curve, so the outer surface stretches more sharply. In basic bending mechanics, strain grows with distance from the neutral plane and falls as bend radius increases. That makes a wider internal loop attractive. But this is where the story becomes more interesting. Lower strain does not automatically mean a less visible crease. A perception study compared different crease shapes and found that depth mattered more than radius. In its prototypes, a deeper crease was easier to see, and a broad profile could still catch the eye. So engineers are solving two linked problems. They need a path gentle enough for the materials, then a surface profile shallow and controlled enough to disappear into the image. Stress lives inside the stack. Visibility happens at the surface. That is why the hinge is more than a door hinge. It is a choreographer. As the phone closes, the mechanism controls where the display is supported, where it is allowed to bow, and how much slack enters the folding zone. Many modern designs let the screen form a rounded droplet inside the hinge instead of pinching it into a sharp U. The display can travel a longer path through the center, while the two rigid halves still close together. Support rails or patterned plates then hold the screen flat when open and yield where it must curve when closed. Samsung does not publish the Fold8's complete internal geometry, so we should not invent it. What Samsung does say is that the new structure balances hinge mechanics, display tension, and magnetic force. Those forces have to agree. A hinge can create a generous bend path, but if tension pulls the panel too hard or support disappears too abruptly, the surface can still telegraph the fold. Now we can read Samsung's Fold8 claim without the marketing fog. Its new Flex titanium structure adds two titanium-based parts beneath the viewing surface. Samsung says a very thin titanium alloy film below the OLED is 20 times stiffer than the polymer film it compares against. Beneath that is a titanium plate with micro-patterned holes in the folding region. The holes let a stiff support flex where the phone bends. Samsung also says the plate bonds more closely to the display module by removing air gaps at the adhesive interface. In plain English, the design tries to be firm and flat when open, compliant along a controlled line when closed, and tightly supported in between. That does not prove every durability claim. It does explain why material choice, hole pattern, bonding, hinge force, and display tension must be designed as one system rather than as separate upgrades. Even a shallow crease can shout under the wrong light. A flat screen sends neighboring reflections in nearly the same direction. Tilt a narrow strip by a fraction, and that strip redirects the ceiling light toward your eyes, while the rest of the display stays dark. The result is the bright seam people photograph. Move your head, change the lamp, or fill the screen with a bright image, and the same surface can look almost flat. That is why reviewers can honestly report different experiences. Tom's Guide said the Fold 8 crease was much less visible, but could still be felt. Tech Radar found it minimally distracting, unless the light caught it. Samsung also uses a low reflection finish, which can reduce the contrast of glare without changing the underlying bend. Hiding a crease is partly geometry, and partly managing the light that reveals it. So did Samsung solve the crease? Not in the absolute sense. It changed the compromise. A stiffer backing can support a flatter open surface, but the folding zone must still flex. Softer adhesive can relieve stress, but it must recover and keep every layer aligned. A larger internal loop can reduce strain, but it consumes space inside a phone that is also being pushed thinner. Stronger magnets can control the close, but they change the force your hand feels. Every improvement moves load somewhere else. And launch week reviews answer only the visual question today. They cannot tell us how the stack will look after months or years of heat, pressure, pocket dust, and repeated folding. The honest verdict is narrower and more useful. Fold 8 offers credible evidence that the crease is less conspicuous. Long-term fatigue remains a test that only time can run. The crease, then, is not a defect that one miracle material erases. It is the signature of a layered machine being asked to become two different objects. Closed, the center needs room to curve. Open, it needs enough support to look and feel like one surface. The hinge chooses the path. The stack shares the strain. The backing restores the plane. The finish manages the reflection. Fold 8 appears to hide that signature better because those parts were tuned together. The next time a folding screen looks perfectly flat, move it under a lamp. If the line returns, you are not seeing engineering fail. You are seeing the compromise it learned to hide. Subscribe to Yapnetic for more stories where everyday objects reveal the systems inside them.